We're on.
Okay.
All right, we have so much content to get through today because there's so many hidden gems that we really just want to get into this. There's a lot of people in here. If you are uncomfortable, we have been told to tell you to go to the overflow room. It might be more comfortable for you, but I love seeing everyone crowding the staircases. That's fantastic.
This is awesome.
If there is a fire, I'm sorry, you're all going to die. But it will be worth it because you will learn about some stuff that we don't know. All right, we have David.
I'm David.
We have me, Damian. Let's going to get right in it. So you've probably heard about all this stuff, right? Just all the stuff in .NET Core 3, Blazor, gRPC, WinForms, and WPF, HTTP2, new JSON APIs, Signal did some stuff. We're not going to talk about any of that today. You've seen all that stuff. You can go read the blog post about that. We're going to talk about all the commits and all the PRs and the issues that you probably haven't seen unless you're following GitHub like a hawk. So let's start right down the bottom at Core CLR. So we have new support in the garbage collector for defining limits about how much memory your application will use. We also have new defaults to those limits so that you'll use less by default. So you can set limits for how much memory the GC has available to it. You can set it to a percentage of the amount of physical memory on the machine, or you can say, I just want you to be able to use 500 megabytes, okay? You can set that via environment variables right now, and there is a runtime API you can use to get information about those limits. Why is that interesting? You might have code that wants to know how much memory is available before it does something, okay? The new defaults use much less than before. So if I switch over to this graph, this is a graph of one of the ASP.NET Core, the plain text benchmark, and you can see that in sometime in April, we went from using, oscillating between 300 to 500 megabytes of process worker set address space memory straight down to just under 100. Okay, and that was a combination of a few things, but one of them was these new defaults. In 2.2, this test used to use 1.3 gigabytes of address space memory. Now it uses 100. And that is partly thanks to these new limits here and these new defaults. All right, moving on. Assembly load context. This is a new API. It was available in previous versions of .NET Core, but it's much more powerful now. You can use this to build a plugin model. Who's ever used app domains before to build plugin models and applications? Okay, that's fantastic. App domains don't work in .NET Core. They're not there. So this is the replacement for app domains. It determines the assembly paths for a given application path and assembly name for you using this assembly dependency resolver, and allows you to tap into the built-in logic in the host that knows how to locate an assembly, locate its relative assemblies based on where the application was booted from, et cetera, et cetera. People heard of Fusion, the old assembly loading stuff in .NET. That's gone, okay? There's a much simpler assembly loading algorithm now. This thing taps into that. Simpler, yeah. You can unload these contexts to free up memory after you've stopped using the assembly, which is fantastic. That was the big thing people wanted. You can resolve both managed and native assemblies, which was one of the really hard things. Now that we're cross-platform, it's very common to bring in different native assemblies for each platform that you're going to with your library or your application. You need to support that. It is not an isolation boundary. The process is still considered the security isolation boundary, or a VM if you really want to go hardcore. This is not an isolation boundary for security purposes. It does isolate the assembly identity and the type identity, and it does isolate things like static values, but that's it. Okay, so don't think of it as a security thing, and it is the success to app domains. You have a demo for this.
So just to warn, these demos are pretty lame.
No, they're focused.
They're focused demos for the short time frame we have for so much content. All right, so I have an app here that's going to show you how to use the assembly load context. So the app itself references JSON.NET, which is 12.0.2. And the application has a main. It's a very simple console application. I'm going to create a custom load context, and you do it by creating a class that derives from assembly load context. It overrides the method called load, and this gets called every time an assembly load is requested. By default, if you don't implement load, it'll go to the default context and use the built-in logic.
So there's no change by default?
Yeah.
Okay.
So if I run this application, it will create a load context, my load context, load JSON.NET into that context, and then it'll get a type from that context, JObject. We call it JObject. JObject.
Okay.
Make it happen.
Make it a thing.
I create a JObject, and then I cast it to the JObject. So by default, there's two load contexts. Well, by default, there's one. There's the default context. So this type that I'm using in the main is in the default context. This instance is coming from a different load context, right? So by default, this should just work if I cast.
Because you didn't override any logic.
I didn't override load, so it should be all the same context.
The same types, no isolation.
Wrong method.
Wrong project. That one.
Yes, start a project. Hit F5. run, load assembly. It's loaded, not special. Get type, create object, cast. Super lame. Perfect.
Worked.
Now,
okay.
To make this work, I'm going to load this assembly in a different load context. Same assembly, same path, different context. So think of it as a different instance of that assembly. So the first thing I'll do is create an assembly dependency resolver. Dependency resolver. In the constructor, I'll new it up with the path, the base path for the application itself. And I will in here say path equals resolver.resolve assembly path. This will give me the path to the assembly wherever the host found it. It could be in the packages folder, it could be in the bin folder, it could be anywhere the host would load it by default. If path not equals to null, I can return load assembly from path, passing in the path. This will load that assembly into this load context, right?
So now we've created that isolation. I've loaded the same assembly into my own context.
The same DLL, but in a different load context. So now I'm going to pass in the path to this application here. So type of program .assembly .location. And now if I run this, let's see what happens. Hit F5. Now I have a new load context. I call load. Still same deal, all good. Create the jobject. Boom. Error. It's because I now have two load contexts, same type, same assembly, like name, but different instance.
It's like I cloned it and created a different instance.
So the error is bizarre. I can't cast jobject to jobject, right? But they're different load contexts.
Okay.
So this shows how you can have a different boundary of isolation if you want like plugins to be loaded separately.
Okay.
The one last thing I want to show is that there's an overload here. I can pass base and say unloadable is collectible. If you unreference the load context on all types inside of it, it'll get GC'd by the garbage collector.
Cool.
All right, so back to the wait.
All right, sweet. All right, startup hooks. So this gives you the ability to register code that will run before the application's program main. All right? So you think about ways that might be useful for you. You do it by setting an environment variable when the application is booting, or just before the application is booting, with the path to an assembly, okay, and an assembly name for the runtime to go and find.
Path or name,
sorry. Path or name, and it'll go and find that. It'll then look inside that assembly for a type with a specific shape, right? It's all pattern matching kind of magic. And then it will call that method and run that before program main. Okay, now there's a whole bunch of things you can start your demo. There's a bunch of things that might want to use this. So if you're using Application Insights, or I think Service Fabric uses this in Azure, so that they can inject code into your application once your application is running in their context. So you don't have to take a dependency on their SDK and add a package. You just run your app in Service Fabric, and then they can inject extra magic into you when you're running there. Okay.
All right. So here's a basic console application. File new project. Prints hello world. In launch settings.json, I have this environment variable that I set called .NET startup hooks with a full path to a hook. See blah, 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 my hook.dll, right? My hook is right here in the same project. It has to not have a namespace. It has to be internal. This worked before.
It did work before.
Internal class startup hook is the hard-coded name that's hard-coded in the runtime. And public static void initialize.
Why is it not an interface or a type or anything? Just as a
to not have dependencies in the runtime that need to be
fair
in
enough.
your app itself. I
mean, goosey.
It could be in there, but it's I don't know actually.
Okay.
Good reasons, I bet. If I run this application, it should print out this before the hello world.
Okay.
Yay.
Okay. So we got your program. Okay, perfect. Yeah. It worked.
Just to show, debugger, because kind of.
But it worked.
Was that lame? Was that a lame demo?
We've got more slides.
Okay, go ahead.
So I'm sure there's like 3 people in the audience going, I'm going to use that. That looks fantastic. All right, diagnostics improvements. .NET Core is now cross-platform, as you all well know. As a result, we don't have the benefit along the deep history of Windows diagnostics and performance analysis tools that a lot of us have been relying on for .NET apps for 20 years. And so we've had to do a whole bunch of investment to bring up a stack of new diagnostic tools and diagnostic hooks so that you can do this stuff cross-platform. So we have a new set of global .NET tools that is releasing along with .NET Core 3. .NET Counters, .NET Trace, and .NET Dump. And you can probably imagine from their names what those 3 tools do. We also have a default diagnostics pipe that is open for every .NET Core 3 application by default. So you just start your .NET Core 3 up. Every one that you were just running has a hidden pipe that is opened that you can attach to get diagnostics information. That pipe is ACLed with the same process identity. So you can't just attach to it if you're not also running as the user that the app itself is running as, okay? So it is secure by default. You have runtime APIs for accessing runtime counters for GC and ThreadPool and those type of things. There's also a new SOS command called dump async, which is useful for diagnosing async or hangs or blocked or hung tasks and those type of things with like just a nice dump of information that's relevant to that. There's also now the ability to force the process to dump when there is a crash. So if you have an unhandled exception in your application and it unwinds, or a background exception or something like that, you can set this com+ variable before applications start, and then the host will force a dump of that if the application crashes. So we have a demo of a bunch of these new tools, right? Stuff. All right.
All right. So I will use this application. It's a website. We're going from console to web. This file new, I think, API has a weather controller. This is brand new. You saw it here first. So before, yeah.
This is the new one in the template. In Preview 7, this will be the new values controller.
It's super useful.
Yeah.
Returns weather in Celsius and Fahrenheit, I guess. All right. So I'm gonna start this process. Oh, I want to change that to something else. That's fine. Basic application, very lame, bad demo. But I can run a tool that I happen to have in one of these applications, one of these windows. Oh.
That's awesome. And James is talking to you.
.NET.
Bye, James.
Counters to get who's ever used performance counters on Windows?
Perf counters, right? Perfmon.
This is the replacement for that, the cross-plat replacement for .NET Core.
Right.
So I can run .NET counters list processes to see what things are running. And I don't, oh God. Which one is it?
Backend, .NET, IS Express, and IS Express.
Or I could just run the app itself.
That makes it easier to
Probably
find.
Easier.
Perfect. And that's not working right now. Call back later. 405.
405?
That's an interesting error.
What? Oh, no.
It's all right. Clock's still ticking. It's okay. It's not like...
We got time, right?
Sure.
Like an hour.
Fix it. Go.
405? Wait, hold on.
That's the wrong app.
Too many apps running. Oh, I have an idea. I have a really good idea. Add value. Do some stuff.
So.
Dance.
Dance? Really?
Something.
Make your demo work. Kill.
Nothing right? Oh, good. All right.
So when we said we'd do this from one machine because it would be better, now I'm regretting that decision.
This is going to be... All right, so this should run, and I should have one thing running that works. With the one process running. That's IS Express. So I'll run .NET counters monitor -p this thing 8368 system runtime and Microsoft ASP.NET Core hosting.
Cool.
Yep. So here are the counters on my screen for ASP.NET Core and for the runtime. Under CPU usage, working set, things that are all useful. You can read the screen. So I'm going to hit this with a bunch of load now. Hopefully, get this endpoint. In some useful window, I have a tool called Bombardier. It's a tool to create load on the site, like AB or work. Let's hit. Oh no, it didn't cut properly. Hit this endpoint. And here. Duration like 6 seconds. All right.
All right. So the numbers are moving.
There's the RPS. There's the total request. There's the current request. Allocation rate, bytes per second. Super useful.
Great.
For production.
So if you've ever monitored performance counters to look at this type of information. This works cross-platform. You can do this today. You can try this on the latest preview bits. You can install these tools as a .NET Global tool from NuGet, and you can see this stuff.
All right.
You got another tool to show us?
Next, so now if your perf sucks, you can run .NET on the same process. Run .NET trace collect, and it will use all of your hard drive space.
I heard hard drive space.
That makes
cheap.
me super
cheap.
fancy. Okay, is it done?
That's an M. As long as it's an M, you're fine. When it changes to
Still
a G,
running
you
load.
can start
Creating
getting
load.
a little upset.
All right.
If it changes to a T, just give up, close it, and we'll walk off stage.
Petabytes. All right, so now I should be.
P? How big is your laptop?
should be done.
Wow.
It's a supercomputer.
Straight to the cloud.
Yes.
Yeah.
All right. Trace is done. Now I have a trace in my user. Oh gosh.
There it is. Trace.NET perf.
I didn't want to put it there. There's a new file format called netperf. I think it's getting renamed.
That is the.
But it is right now netperf.
Right now it's netperf.
And you can open it in.
No, that is the new name. It was netcollect or something, wasn't it?
It was netperf.
nettrace. It was nettrace.
No.
Now it's nettrace. It's going to be nettrace.
Nettrace, right?
It's now netperf.
It's going to get renamed to
nettrace.
nettrace. Okay. Right now it's netperf.
Naming is hard, ladies and gentlemen.
So you could use. Did anyone here use Perfview?
Few people.
On purpose. Okay.
The profiler in Visual Studio. Anyone use the CPU profiler in Visual Studio? Okay, yeah, a few people.
Yeah. All right. So
.trace, JetBrains.trace.
It now supports this new format. Let's open this file format.
You have to do it in a fresh instance, don't you?
You didn't see that.
Okay.
And it will load the CPU tools, and I can see what is slow in my app.
Ooh. Now, could I have collected that on a Linux machine?
Yes, you could.
And then brought this over to VS?
That's right.
Lovely. That's something that's really hard to do today.
Yeah.
So now you can just take that trace from your or inside a container or whatever it might be, and then just bring it over to VS, and you can use the existing CPU tools. Awesome.
Things.
Anything else?
One more thing that doesn't super well yet.
Oh, then maybe that's not worth showing if it doesn't work super well.
Okay. Show the tool.
Okay.
There's one more tool that totally works sometimes.
This is the .NET dump tool, right?
Yep.
Okay.
So I have
So on Windows, creating a process dump is fairly straightforward. You go to Task Manager, you right mouse click and say create dump, or you go to get procdump.exe from systemterminals and you run that and you have a dump. On Linux, it's not so straightforward. Now there are some tools that the .NET Core team had shipped previously in the runtime. Create dump.
It is now.
Inside the runtime. But now we have one tool to rule them all, no matter where you are. .NET dump that works really well. That will create a dump for you, okay? No matter where you are, with the heap information so that you can do the memory analysis for the snapshot afterwards. So
and you can also do .NET, if this worked. It does sometimes. It didn't before I came here, so.
Right, so I've collected a dump file.
Analyze the dump file, what's it called? Dump.
That one there.
And it gives you a command line app to analyze your application. I can run help to see what commands there.
Is this like SOS?
This is basically SOS built in without having a debugger.
So you use SOS in WinDBG for .NET. Right, so now you've just got it here. And again, could I have taken that dump on Linux and then brought this over to Windows and run this command? No.
No.
Okay, that's unfortunate. It's close.
Not
We're
yet.
so close.
Not
We're
yet.
working on it.
Let's see if this works yet. Dump heap.
Okay.
Yeah, I got this morning, but
Okay,
I
never
think
mind.
threads work.
Okay.
See threads, and not the name, but this super not useful.
But with the
information.
with WSL2, right, on Windows,
Yeah.
with the kernel, with the Unix and the thing,
Yeah.
I could run this inside WSL2 and with Linux and
hope it'll work.
and hope it'll work.
Yeah.
We're working on all this. We're trying to make it as easy as possible
Wait.
for you to use this stuff across platform. Turns out it's quite complicated. All right, we're good?
Resume slideshow. Oh yeah. that
Excellent.
works.
All right, publish options. So there's 3 new publish options in .NET Core 3 that enable you to optimize your published application in different ways. Some of these currently are kind of laser focused on the WinForms and WPF desktop app scenarios, but they're not limited to those. You can use them for all application types, console apps and even web applications if you think through it a little bit. So one of them is ReadyToRun. Most of you, I'm assuming, have heard of NGen with .NET, which lets you pre-JIT, except that runs on the target machine. You don't really run NGen as the developer. You run it after it's been installed on the machine, and so it makes it a little inflexible. So we have this thing called ReadyToRun, which pre-JITs your application. During publish, it'll generate ready-to-run images for your application along with the managed images, and they'll all get shipped together. It is a form of ahead-of-time compiling or pre-JIT, which, as I said, similar to Engine. You do get slightly larger files because it does mean that you take over a little bit of native code as well as the original IL code with your application.
Slightly?
Slightly?
How slightly?
Quite a lot slightly, yes.
That's what I thought. That's what I thought.
You know, just like I am slightly smarter than you. Maybe slightly better looking. I don't know. We'll just keep doing this.
Whoa. Both fake news. Both fake news.
And then after the application is started up, the new tiered compilation system, which was optional in 2.2 but is now on by default in 3.0, will identify hot paths of your application and then re-JIT those with ever more enhanced or better JIT algorithms, which may be a little slower but will produce faster code. Okay, and that's really important because the ready-to-run images themselves are actually slower at runtime. They're faster to start because you don't need to JIT them, but they can't generate as efficient code because they don't know what CPU you had ahead of time. And they can't optimize things like inline code across assembly boundaries and all these types of advanced things when it comes to JITting. So the combination of ready-to-run images and tier compilation, in theory, gives you the best of both worlds. Okay?
Can you publish to other platforms? From Windows, can I publish for Linux?
So you'll note that there in the command line, you have to pass the target platform when you do ready to run, okay? Because you have to know where you're going to generate native code. The question is, can I do that for another platform? And I think the answer is it depends.
Just say yes.
Yes.
Yeah.
Okay. Have we made that work for everything?
I'm
like,
sure,
can you
actually.
do ARM from x86? I think ARM from
ARM,
you have to be x64 at least. Yeah. Anyway, so maybe is the answer. Publish option single file. A lot of people have indicated that maybe when they publish their application, they get a little sad when they see hundreds and hundreds of files in the output, especially if they're doing a self-contained application that takes the whole .NET Core runtime and shoves it in their application with it.
Just zip it.
You could just zip it, but then you have to do it yourself.
Oh, sure.
Then you have to deploy it. Then you have to unzip it. Okay, but this is effectively what this does for you. So you can say now /p or put this in your project file, publish single file true. Again, it needs a RID, so it can generate you the native executable that will launch your app. But then you have one file. It's pretty big, because it's a big file that contains your entire application.
It's huge.
But it works for both framework-dependent .NET Core apps and self-contained .NET Core apps. And then you have a single file. You can take that over, you can run it. It'll self-extract itself to a temp location the first time you run it, and then it will run from there. Then the next time you run it, it'll detect it's already extracted itself, and then we'll run from that location. Okay? It's pretty cool. And then lastly, we have assembly linking, which is a little like in the old days we had. No, it's not like that. It's not like IL merge. It's from Mono, and it's a set of technologies that will look at all the code and try to statically analyze parts of your application or code base that aren't used, okay, after it's compiled, and then tree shake those out, okay? You can configure it because sometimes it can't figure that out, and it will shake things out that it shouldn't have shaken because you're doing like light up or reflection or those type of things. And so you can tell it, hey, I know I really do need that assembly or that type. Please don't get rid of that. And again, you can just pass this through publish, give it a RID, and you're off to the races. And you can use all three of these things together to give yourself, ready to run, pre-JIT, plus assembly link trimmed out, plus a single file.
Does that work?
Not in Preview 6, but it will in Preview 7. And you have a demo of using one or two of these at least?
I'll try it.
Okay.
This command actually, forbidden. Okay, so I have an application in one of these windows somewhere. This one. Nope. All right. So same app I just ran, the ICE application. I will maybe stop it first. Aggressively stop it by killing it.
Damn, you just got violent.
.NET. .NET publish /p. Was it single file? It's true.
Publish single file true.
Ooh. Publish single file true. /r when x86.
64. You're on 64.
8x86. All right. Publish. Let's see what happens. Crunching everything together into one file, just like crunching it all.
Crunched. Done.
Crunched. It's done. It's crunched. It's super. Look at that.
Look at that. Lovely. It's kind of one file. If you don't look at the other two files. I mean, obviously the PDB is separate. There we go.
It never was.
Never there.
This file is I mean, is that too big?
77 meg.
It's huge.
It is kind of big. But, you know, it's only a preview. We're going to keep working on it.
Yeah, and also my config file is gone.
Yeah.
Where'd it go?
Well, you just deleted 2 files that you.
No, so there were 3 files. One was web config and one was the PDB.
Yeah.
Where's the?
So by default, right now, this was a web app. Is a web app. Right now, as I said, this has been targeted at the desktop application scenario, and it works perfectly for that. For web applications, ASP.NET Core's default locations that it looks for stuff has not been updated to allow it to find things from the temporary location, from a place that's different to where it launched from. We do intend to do that at some point, but what we're going to do in the meantime is update the Web SDK to not bundle static files, right? So the Web SDK today, so it explodes horribly. The Web SDK today will, by default, look for JSON files and images and CSS and JavaScript, et cetera, during publish and copy those with your application. You don't have to say all that in your CS project, it just does it automatically. And then the bundling tool here just goes, oh, great, I'll suck all that up and stick it inside myself, and then I'll extract it out to the temp location, then we boot from here. Yeah, I know. And then we'll stick it in here. It was hungry. And then it will... when it boots from here, we go looking for those files in this folder and we don't find them.
It was slow, actually.
Yeah.
So the first one was pretty slow.
Yeah, because I had to unzip. I had to unarchive 77
crashes
megabytes over to thing. All right. Hey, you want to fail quickly. So you can work around this right now if you put a little bit of MS build goop in your project file just to tell it to not bundle the static assets that you need to make the application run from that location. You can do that. There's an issue logged that has this details in it, but we will make this work. As I said, more targeted at console apps and desktop apps right now. For now. All right. Anything else on that?
Yeah, one more thing. Publish. I need like one window. This is that one. This is this one. This is a good one. All right. Publish. What was the last one? Publish. Trimmed.
Trimmed. Publish trimmed. This is the assembly linking.
All right.
This is the same app?
It's trimming. It's trimming super hard.
Is this the same app?
Yep.
Okay.
Getting rid of assemblies, doing advanced analysis, erasing functional features.
I don't need that.
I think it does, right?
It's going all KonMari on your application.
So here's the bin folder by default. And here's the size without, where's the button? Size without, without being trimmed. 76 megs.
Okay, 76 megs on disk.
But after a bit of exercise and diet, the new size is...
I see less files too.
40
wow,
megs.
Okay, 46 megs. That's not too bad. Does it still work?
Not sure.
Okay.
But if we erase the folder and move on to the next slide, it doesn't matter.
Okay, fair enough. So it does work fairly well for, out of the box works fairly well for simple applications, but as I said, once you start doing things a little more advanced, which ASP.NET Core does by default.
Advanced or like reflection?
Reflection.
Yeah.
Which, not everyone does, but it might do it underneath you without you knowing, like ASP.NET Core does.
For you, yes.
Yeah, for you. Then you may need to instruct the linker about some things. All right. So native interop improvements. For those folks who are doing native interop, which is sometimes common in Windows desktop applications, which is one of the reasons we're bringing it into .NET Core 3. We now have support for managed C++ CLI. COM interop is now supported in .NET Core. Obviously, these two only work on Windows.
And
only work on Windows and WinRT. Only work on Windows, but you now have first-class support for doing all of those from Windows .NET Core 3 applications. There's a new type called native library, which is kind of the imperative equivalent of DLL import. And so rather than decorating a method stub with DLL import, you can now imperatively load native assemblies and use the CLR's logic to go and find where they should load from and do all the goodness there. You have some samples for this?
Yeah,
is
does
it
anyone
worth
care
looking
about
at?
COM?
No, no one cares about
Anyone
COM.
does COM?
Let's go.
Daily?
All right, so
Yeah?
MISC for course, there's not much here either. ARM64 support. So this is a brand new architecture that we support now in .NET Core 3, or for Linux only right now to start out with. So if you're running Linux IoT, for example, on top of an ARM64 board, or you have an advanced scenario where you've got a Linux server that's ARM64, that's a thing, I've heard.
Maybe.
Then we do support that. And then also we have hardware intrinsic support now so that you can, from managed code, detect if your CPU supports like AVX 512, if you've got some super expensive Xeon processor, and then utilize those APIs from managed code to do vectorization and all that type of wonderful stuff. Advanced stuff. The inbox UTF-8 encoding which is obviously very relevant in web applications, and ASP.NET Core uses by default, has been fully optimized using all of these new hardware intrinsic supports. All right, let's move out of the CLR and up into the BCL. APIs for everybody. All right, iAsync disposable. So you have a disposable object now. You can implement iAsync disposable, which will allow the runtime to dispose that using an async code path. This is particularly useful for cases where you have like a stream or anything doing I/O, where if it gets disposed while it still has a buffer internally, during dispose, it will implicitly flush the buffer to whoever was listening on the other side. Today, that can cause real problems because that now blocks the thread because it was a synchronous code path. Dispose today is a synchronous call. If you then have to do an async flush, you have to wrap that with a synchronous call, and you end up doing this, which is super bad.
So this looks safe. You do a using, you do await, stream write async. This is buffered, and dispose will then call flush synchronously.
Yeah.
Which is bad.
Which is super bad.
So instead, you could call flush async yourself, or in C#8, you can do await using this.
Right. And then if dispose does get called, and it does have a buffer that it has to flush, it at least can flush asynchronously now and not block the thread while it's happening. So that's all goodness. All right, distributed tracing. For those who have more complicated service scenarios where they've got one app that then talks to another app that then talks to another app, microservices, front end, back end, all that type of thing. We now have updates to the existing activity type, which it was introduced, what, 3 years ago?
2.1.
.NET Core 2.1 and in .NET Framework, or support for .NET Framework, to support the new W3C trace context standard. It is on by default in ASP.NET Core 3 applications, so that if an incoming request comes in with the right header format and name, we will turn this on and then flow that information out through HTTP client if you make an outbound call again. Now you can have correlated logs for that logical transaction that runs through one app and then jumps over a process and goes off to another app. And it integrates with OpenTelemetry, which was previously called OpenCensus, to give you that Zipkin style sort of distributed tracing. Do you have a demo of that that's worth showing?
Maybe.
Maybe?
Let's see if it works.
We'll let them judge whether it was worth showing, I guess, afterwards.
No.
That one red card will be the one that someone says that wasn't worth showing, that OpenCensus thing.
Okay, so let's take the app from our workshop that we did last week. There's a front end and a back end application. The front end is Razor Pages. The back end is an API controller. So very simple controller, and the back end does basic stuff, right? EF with MVC, so not a big deal. I'm going to run the application so you can see what it does. It's a conference planner. It has these talks from the conference right now.
I just want to point out, scroll down. There is someone here whose name is literally Lemon with the Unicode character for lemon. I thought that was fantastic.
We found it, yeah.
Yeah, it's awesome. And they're going to apparently make you stop hating CSS.
Apparently,
I want to go to that talk.
So the front end calls the backend API. Very simple, right? This is a microservice design. So
microservice. 20 years ago, we just called it like ntier. It's just what it's the same stuff.
It's a database per app, so it's microservice.
Okay, fair enough.
Not ntier. So there's a type in .NET Core since 2.1 that people may not know about called activity. Does anyone know what that type is?
Activity? No.
Like one hand, 2 hands. The people that work at the company that does. Okay, awesome, great. All right, so activity is basically the current. Think of it as an ID for the current contextual flow.
Ephemeral state.
It's an ephemeral ID
that flows
across
boundaries.
So if you want to have a front end called the back end, you want to flow an ID from the front end to the back end and add. As you go from service to service, you want to track all the calls from in and out, so track times, right? So by default in .NET Core 2.1, we added this type, but it was really hard to use. So the goal was in 3.0 to have it on by default, and have things plug into it, so it would light up in different situations. So if I look at activity, the type itself, just to show what it does. Activity. It has a current. Current has a bunch of properties. The thing that's interesting is the ID. The ID is the current span ID. There's spans and there's traces, and you can create child spans that are child activities. So imagine request comes in, you make a database call or several outbound calls. Those are all individual spans, and there's a kind of a parent hierarchy going on here.
So you kind of imagine the waterfall view in the Chrome dev tools of this called that, and this called that, and this calls that. This enables that, but server side.
Right. So ASP.NET Core creates one on the incoming request, and HTTP client will create one on outbound request.
And correlate them.
Yep.
Right.
So by default, if I put a breakpoint in the backend code, I guess we have one here for sessions. I should see an incoming request header from the front end by default without having done anything.
Okay.
App runs, hits the back end. If I look at the autos, obscurely dive into the debugger window, into request, into headers, into something. Here, header trace parent. This is the actual header that flew from the HTTP client. So HTTP client on the request from the front application added a header called trace parent, which is the W3C trace context standard header that flows to the backend. The backend will get it and create another activity for its request, and then other requests will have other activities. Right?
Okay.
What you can do with this is plug into something like OpenCensus or Knuckle OpenTelemetry to get a waterfall view. So in my startup in the backend, I have this awful code that will get cleaned up at some point. I'm using this thing called Zipkin. Does anyone know what Zipkin is? Zipkin, yeah?
Yeah.
It's a distributed trace view made by Twitter. It's a tool that just shows a waterfall model. So I have one in the front end and one in the back end. Hopefully this works. And I was told that I have to make the call take longer to make it show.
To make it show something useful.
So let me add some latency.
That's a lot.
Perf bug.
Okay.
Just in case, for good measure.
You're creating opportunities for future improvements.
All right, so this should be running.
That's how I'm a manager.
Isn't that what you do when you plant? Isn't this how devs work? You put one sleep in there so you can look like a hero.
Except you put it in a region, so it was collapsed. And then
put it in a region. That won't pass code review. So to make this work, I had to do something. I had to Docker some stuff.
Oh.
So I'm going to run Zipkin. Zipkin is a Java.
Port's already allocated.
Okay, let me stop this thing.
You've already got it. Oh.
It looks dead. Stop this container from running. And there's Zipkin, and there's Jaeger, and there's a ton of other tools, Dynatrace, and App Insights, and all kinds of tools to do the actual viewing of the tracing.
Right, to ingest this and then make something useful of it.
Yeah, so OpenTelemetry basically takes our events, turns them into generic spans that are passed to Zipkin or different exporters to run the end-to-end scenario. So if I run this now, I should have a view of sorts.
Okay. Do you have to make a request to have some logs show up?
I do.
Okay.
I do need to run the application at some point.
How is Zipkin reading from, like, where are the logs going?
If you look at this configuration, the configuration to Zipkin says use this endpoint.
Oh.
Which is kind of weird.
So you said there's middleware in the two apps that's available.
So each app is posting data to Zipkin.
Got it.
Via OpenCensus.
Okay.
So that, they run the right app?
Did you run it? No.
This one. So run the application again. The only weird thing is that the actual traces to Zipkin show up as well.
Oh, that
must be a bug.
So, okay.
So it's running, it ran. If I look at Zipkin, I should see something.
There you go.
Span, one span, two spans.
Is there a waterfall-y thing we can see?
I couldn't get it working.
Oh.
But in theory, this works really well.
Okay.
But it's showing the actual trace.
It's still preview. All right.
This will work end to end. I just didn't get it
by the time we ship.
And this will not show up because this is kind of weird.
Okay.
Show the actual
it's tracing it, showing itself tracing.
Yeah.
Okay. Cool. Nice.
Right.
So we're making progress there.
Yay. It kind of worked.
Back to the slides. Sell it, man. Sell it. Right.
Yeah.
Runtime feature detection. So if you have a library or you're doing any type of code that wants to emit code at runtime, this is quite popular for serializers or dependency injection containers or even ORMs and any other like automapper, things like that have to generate code at runtime and then compile it to make it faster. You need to be aware of what features the runtime has available to it. You might be running on iOS because you've got a Xamarin app and then there's no JIT available to you, okay? But you might have an interpreter. You're running in .NET Native in a UWP application. Again, no JIT, but you have an interpreter available to you for expression compilation. And so we now have these two flags that you can use to detect the conditions of the runtime, and then you can make a decision as the code author about what it is you want to do. Do I support dynamic code being compiled, and is dynamic code even supported at all, okay? ThreadPool enhancements. Okay, this is another one of those things that has helped us improve the performance of ASP.NET Core in version 3. One of them is unsafe queue user work item, which does some advanced stuff with a thing called execution context, which great, that's fantastic. iThreadPool work item is much more interesting. Now when you enqueue work into the ThreadPool, you can implement your own type that the ThreadPool will then dispatch to. Okay, so rather than the ThreadPool behind the scenes creating things every time you say run this please, run this please, which has a memory overhead, you can implement your own type and you can have a single one of those that caches things and clears things in between runs, which is what we do in Kestrel. And it's what we do in the IIS module, so that when we're doing millions of requests per second and we're dispatching all of those I/O callbacks through the .NET ThreadPool, we're not getting any overhead by doing so when it comes to memory, because we get to manage all of that inside our own type. All right, some miscellaneous stuff in the BCL, support for process.kill and support and including the entire process tree, which wasn't there before, so you can pass that now and kill all the child processes of a process. Bit operations type for doing advanced bit twiddling for people who are really into like math and image manipulation and other stuff like that. Sound wave, sound files, I guess, I don't know. Microsoft Visual Basic is back. So if you're trying to port an application for like a WinForms or a WPF application that was written in VB to .NET Core 3, this is kind of important because of all the VB specific namespaces and functionality. My.dot, for example, yep, back in .NET Core 3. And then a small one, DB command, now supports async transactions. So if you're doing begin and end transaction, when that transaction ends, you can now, or even begins, you can call that asynchronously because there is I/O involved, you are waiting on a database, there's now an async version of that available for you. All right, up into the server stuff, ASP.NET Core. UnixDomainSockets is now natively supported in Kestrel without having to use libuv. So we used to be based on libuv, the native library that gave us cross-platform I/O. It was the same library that Node was based on. In ASP.NET Core 2, we did the work, or 2.1? 2.1, we did the work to replat on top of the system.net.sockets implementation by default. Libuv is still available as a package. You can use it if you want to, but by default, since then, we use the native sockets in .NET. That now supports Unix domain sockets, whether you're on Windows 10 or above, or Linux, which is fantastic. It's really good for scenarios where you have a front end, like a reverse proxy, that then needs to talk to your .NET Core process. And rather than using HTTP to proxy there, you can use Unix domain sockets, which is just lower overhead. Okay, so that's on and or available to you by default now. Static web assets in class library, some good stuff here. So if you've got a Razor class library because you've got Razor views or pages or Blazor components that you want to ship as reusable components inside a library, what do you do with the static assets, with the CSS files and the images and the JavaScript that supports that? Well, we now have out-of-the-box default support for embedding those inside of your project, just as part of the build system. You don't have to do anything special. If the files are in the project, we will find them and we will compile them in. Then when you reference those from your application, we know whether it's a project-to-project reference or a project-to-NuGet reference, and we will optimize depending on what that is, and we will set up your ASP.NET Core application to find those static resources. The way you reference them is with this little convention. So in my application now, I would say the source is _content /razorlib1 /hello.js if my name was razorlib1, and then everything just works by default. Okay, it's really, really nice support for doing so. Okay, IIS server variables, another very small one. If you're running ASP.NET Core inside IIS, up until now, you did not have support to read the server variables, which gives you all that really valuable information about how the server is configured, what your connection currently is underneath you to the client, and a whole bunch of information about the request. That's now available to you inside your ASP.NET Core application. System.io.pipeline. So as a refresher, this is the API that was effectively extracted from Kestrel's guts after ASP.NET Core 2.1 that took all the great work we did in Kestrel for networking primitives, memory management, basically an inversion of the socket philosophy in .NET, and we now have that available as a separate set of APIs. You can now get access to the raw pipeline that's underneath your request and response and read and write from that pipe. Okay, and then we've rewritten, or some of the things in ASP.NET Core, shuffled them around to use the pipes directly rather than going through the stream adapter. Right? Usually you would read the body and you get a stream type and then you call all the stream APIs. You can now call the pipe APIs to do that instead.
So form parsing is now allocation free.
And form parsing is now allocated. Well, that's pretty cool. And that is the big advantage of pipes, is because they manage the memory for you effectively if the pipe person is doing that. you get to reuse Kestrel's buffers. Kestrel is already allocating memory to deal with the connection, to deal with incoming requests, and it's managing that memory for you. You just want to read from that and have it take care of it. And so form parsing is a fantastic one because forms can be big. All right, speaking of pipelines and networking, some of the other parts of Kestrel, which was how we internally factored the fact that we have a transport layer and then a bunch of logic that no matter what the transport has to deal with memory and connections and the logic around that, we've pulled out under a thing called Project Bedrock. It's just a project name, it's not an API name, but this gives you the ability to reuse all this logic in your own libraries, whether they be servers or clients. So for example, the popular Redis client that the Stack Exchange folks build is using these, is going to end up using these libraries as well. The .NET Signaler client in core uses these same libraries. And so now we have this really aligned client-server networking abstraction that doesn't care what actual networking layer you're using. Doesn't matter if it's TCP or HTTP or whatever it might be. It just deals with bytes, basically, right? That's all it is. But it gives you all that logic. And we have a WebSocket pipe abstraction. It's how Signaler uses it. So
let's see what I can show here. All right. So this change actually happened super late because the Orleans team, they actually copied Signaler's entire transport abstractions into Orleans. We had a meeting about should we make a public API, so we sat them together, designed an API, and it happened to be put in Kestrel like last month.
Oh wow, okay, this is super fresh.
Super fresh.
Okay.
So I'll do it inside of an application that has web just because it's simpler. There's now a new interface available. I'll write a new thing. This is all unscripted.
Unscripted?
Unscripted.
Okay.
Let's call it server. Server 1.
I think it's good.
You don't trust me?
Oh, it's good. Trust you with some things.
I hosted service. Ugh. This will inject. This will start up when the host starts. I'm going to inject a new interface called iConnection Listener. The names, okay. Give us some feedback. Feels like Java.
Connection Listener Factory?
Just one.
Oh, just one. Okay, that's fine.
Private reader. Listener Factory.
You know that there's a snippet that automates everything you're typing right now.
Does it?
Yes. Just consume it first, and then control dot, and it'll create it for you.
This feels wrong.
See? Boom. Done.
All right, so it's async.
Adding value.
It's amazing. Factory dot bind async, pass again an endpoint. So new IP endpoint. And this can be anything, any kind of endpoint. It can be a domain socket. It could be a file handle.
UDP?
Not yet.
Okay. You said any. I'll log the issue.
Damn it. Port 8001, so it won't conflict with anything else. I'll get back to listener. Ooh. You know, actually, I should do a background service. Probably better. Ooh.
Background listener was introduced in what version?
2.2.
2.2?
1.
2.1 or 2.2?
2.1.
Okay, background service, sorry.
On the hidden.
I don't think we talked about it much.
I checked it in, let's put it in the
okay,
code base.
You just checked in, didn't tell anyone, didn't you?
Yeah.
All right. Nice segue. Background service is a type you can use in your ASP.NET Core apps to run stuff in the background, okay? That's what it is. Pretty cool.
We talk about servers, right?
And it will coordinate itself with the lifetime of the application, give you a chance to shut down, et cetera, et cetera.
So now I have a listener. I can accept async, get a connection. And then
I keep thinking that's like a magician doing sleight of hand. So you just don't look over there, and you do a thing over here.
So the goal here is to have the ASP.NET Core equivalent of the lower connection layer. All right, so you get back an abstraction that gives you a listener to something. Could be TCP, could be name pipes, could be whatever you want, right?
Okay.
In memory. And then you get a connection object, which is your HTTP context equivalent for a connection. And this guy is kind of an abstraction over.
It's looking for you. What did you hit?
Power. I was going for F12, aggressively F12.
We can blame Steve Jobs for originally putting a power button on the top row of a computer.
It's too close.
That looks like every other key.
So here's the context. This is your HTTP context for connections. It has a bunch of basic things like an ID, connection closed, endpoints for your address, and a transport, which is your actual socket.
So to be clear again, this thing doesn't know how the bytes are getting to me.
Right.
I know it's a connection of some sort.
It's something.
But doesn't matter. I'm just dealing with the fact that there are things coming in. I want to send stuff out.
Right.
But the transport layer that was configured separately,
right.
TCP, whatever it might be.
Whatever it was.
Okay,
right.
fair enough.
So for example, I know for a fact this app is running Kestrel, so it should have the sockets transport configured.
Right.
So I'm passing in an IP endpoint because I know that can support IP endpoints.
Okay.
So I get a listener back on this port, get a connection, and then typical while loop you do when you write a server, if you've done it before. Connection dot result. Done it so many times now. Connection dot transport.
So you read from the incoming transport.
Input dot read async.
Okay.
Get a thing back if result is completed. This is the pipelines model if you haven't seen it before. You don't pass in a buffer. One is given to you because it handles that management for you under the covers.
Manages the memory for you under the covers.
Connection dot transport dot input. That's a lot of dots. Result dot buffer dot end.
Demeter isn't watching. It's okay.
I need to move this all the way. So now I'm going to write to the output. Connection dot transport dot output dot write. Async result dot.
Is this an echo server?
To array. Yep.
Okay.
Just to don't judge me. This is a demo. Okay.
Did you allocate right now?
Don't do to array. It's just easier for now. So this does a loop until the connection is over, and it takes the incoming bytes that I got back, writes to the output, and this advances the buffer.
Okay.
In a loop, right?
Right.
Very simple. This is the whole server.
So that's an echo server.
Yeah.
Basically, anything it receives, it'll send it back.
Yep.
Okay. Awesome.
That's it.
I don't know. How are you going to connect to it?
I happen to have putty in my tray.
Oh.
Just happened to be there. Wait, what are you doing?
That looks like it tried to bind to something that's
just
already
died
listening.
Horribly. Okay, this happened before. Who is bound to my port? Who is taking? Oh, you know what? We have XZs now. That's the problem.
Okay.
Before it was easy. Now you gotta search for a real name.
Mmm.
Ugh. What's the app called? Oh, it's not that one. But you know what?
Publishing sample?
I know things work.
Is that what it was?
I know things work, so I can just change this to like 7. This to like 7.
Great.
Woo!
Perfect.
Beautiful. Wait, I should hit debug to see if it works. Hold on. I should put a breakpoint here because I didn't actually hook it up. So I have to actually add this.
You didn't actually. Okay, you haven't actually told anyone about it. You just wrote some code.
Add hosted service.
There we go.
Server 1. So now this should get called.
So I have a background service in an ASP.NET application that itself is grabbing the connection factory from Kestrel.
From the container.
From the container, and then saying, create me a new endpoint on a different port, right? That is going to be an echo server.
Yep.
Okay. Along with the ASP.NET
TCP. So
okay. Using TCP, because I know Kestrel is the server in this case.
8001.
Raw. Okay. Ooh.
Connection. Ugh.
There you go. Nice. I think they get the point. Okay, that's good. Nice.
That was super cool.
Now, if you've ever done that with the existing APIs in .NET, it's not that easy.
No.
Especially not to do it asynchronously and with good memory management and all the rest of it. This one is still tied to TCP, but you could abstract this slightly and have a more generic
Yeah, if you just
echo
change
server.
this to be something else.
To something else, you would be fine. And you could get rid of that buffer allocation if you wanted that to array, if you wanted to
just add a method for that.
Create a thing.
All right,
let's go on.
Bug.
Let's go on. Got more
Myself.
stuff. Sweet. Bedrock. All right.
Ooh.
So we got a new support in routing. We've had this request forever to support route matching based on the host. Right, the request came into this server because my server is bound to multiple host names. Can I please do routing based on that? And forever we said no. And now we're saying, okay. And that's in 3.0 because we have a new system, endpoint routing, and it made it easy. Now it seems like a good time to do it, and it was easy to do. So for example, you could have a controller that only matches when the incoming request came in on a specific host name. okay, which is kind of cool. Very useful for multi-tenancy scenarios where you want to have different host names configured for multiple tenants, and then you want to be able to have different application parts or types that only resolve to that. Or if you want to expose multiple endpoints, like, for example, internal-only ports, and you've got special logic that you can only get to if you're on localhost or something like that. So do you have a demo of this one that's worth showing?
This one's pretty great.
Okay. If you do say so yourself? Okay.
I made it, so it's good.
Okay.
All right, so here's the demo. Very fast demo. 2 actions on the same controller.
Okay.
Same route, different host.
Okay.
So this one should respond to only HTTPS 5001. This one should respond to HTTP 5000.
Okay.
Different name because you can't have the same name as C#. I should run this now, and 5000 is not. You know what? You know what I think it is? Conference planner. No. Conf. It's not.
It's not. All right.
Again. 6.
It's all right. There's a lot of those numbers, so we can do this all day.
Oh, wait. No, it's messed up.
Could I read the config from Kestrel and make that dynamic? I couldn't because this one is declarative. You could add that route constraint.
I made a demo.
Imperatively, right?
Don't ruin it.
Okay, sorry.
You can.
You could, though. It's possible.
It's possible.
Okay. Because I saw repeated strings, and that just triggers me.
Why did that hate strings?
All
right. 6001. There it is. 6000. HTTP.
Doesn't work.
Unsafe port.
Unsafe port? That's an awesome error.
This is... Okay. Hold on.
What does that mean?
Hold on.
You have 12 seconds.
Hold on. Hold on. What?
Unsafe port? I've never seen that before. You want David as your DevOps manager.
HTTPS. Is it that one? Oh, no. Wait, hold on. 6112. 61113. 6112. This is just horrific. On stage.
Okay.
In front of you all.
So this time it's going to work?
I planned this, by the way. This is all planned.
Okay.
Ooh, safe port. Safe port.
Safe port. Is 6000 like reserved or something?
Evidently.
I mean, it's ephemeral, but okay, there you go. Well done. Nice save. Landed it. All right, support for trailing headers. So you can actually send headers after you've sent the HTTP response body. Who knew? How long has that been a thing?
Ever. Forever.
Forever. It's just nothing supported it.
Yeah.
Okay. So we now support that. It was required to support gRPC. And we've got support in both HTTP client for this and in the server. And it's useful for doing things in server programming like sending perhaps timing information about how long it took you to process the request. You can't do that until you've processed the request. So you need to have sent the body first, and then you could quickly append a header at the end that says this is how much time I took. We have made improvements to the developer exception page. We can now send non-HTML responses to clients that don't support HTML. So if you've ever used like Postman to hit your app during development and you get an error and it just sends you back a huge blob of HTML in the thing designed to look at plain text and JSON, now it won't. Now it will send you nice plain text exception details based on the developer environment, which is fantastic. There's also an extensibility hook, iDeveloper page exception filter. And so now you can plug in your own custom view. So for example, if you wanted to send a JSON exception format, you could. For a specific exception, you could. We're going to update the Entity Framework Core specific developer exception page to not be its own middleware, but instead just plug into this one developer exception page just to clean things up a bit. So that's coming as well. We're not going to be able to demo this, but we've got improvements for compression. Up until now, we would not serve anything compressed when you are over HTTPS due to historical security concerns with attacks like crime and breach. But now we've got support for you during the request to say, no, I know this is safe. There's no user data in here that can be manipulated by the client, so you can't do timing attacks and that type of thing. And then we implement that by default by the static file middleware. So now static files will get compressed in ASP.NET Core, and they also support Brotli by default now in ASP.NET Core. Super, super helpful. We did have a number for that as well, but you can do so. You can put code in your Razor page or in a filter, and come up with a scheme for saying, I know that this page is safe. It's not ever showing user input that can be manipulated, and so please compress it. All right, the last layer, we're going to have to burst through this. We've got systemd integration now. If you're hosting a background service like a Windows service on Linux, that's coming in 3.0. It just got checked in like a week ago. The ability to get all of your configuration values in one big dump, which is very useful for debugging. You can do that now with get debug view. You can validate your service provider, that is the container, when it is being built during application start. So that instead of finding out you misconfigured DI like 14 requests into the server starting when you first get a type, you can just have it fail immediately. And that's enabled by default during development, so you can find out very quickly. We now have support for options validation. So if you're using configuration and binding those to options types, and you want to make sure you haven't missed a configuration value, there is built-in support now for writing a method to validate your options, or even using the data annotations that you use on your models in MVC and Entity Framework to validate your options as well. And again, the app will just stop, and then you'll know that you've misconfigured your environment. If you want to use loggers outside of ASP.NET Core in a console app where there's no DI, we've got a factory method that's static that you can do that with right now. And then you can also load configuration sources like JSON and XML and INI and YAML from streams now, so that you can get them from memory, right? From embedded resources or Key Vault or anything like that, not just files, which is kind of cool. That is it. Stuck the landing. Please follow us on Twitter. Ask us any questions. We will make this demo, all the demos, and the PowerPoint available on David's GitHub by the end of the day. End of the day. Thank you very much for coming along. And we are on a panel this evening. Future of .NET. If you want to come and see us talk with a couple of other folks, so I can't remember right now, then do that. Otherwise, thank you, everyone, and we'll see you next time.
Thanks.